Welcome to the Pragmatic Clean Architecture course, where I'm going to teach you how to build production-ready applications using clean architecture and domain-driven design. My name is Milan, and I'm a software architect and Microsoft MVP in developer technologies, and I spent the past 6 years building a number of large-scale systems serving thousands of customers and millions of requests. Inside of this course, I'm going to teach you everything that you need to know about building a modern, maintainable, testable, and scalable system using the clean architecture and applying domain-driven design principles, and you'll be able to proudly ship this system to production. Now let's see what you're going to learn in this course. So what are you going to learn in this course? You're going to learn what the clean architecture is and how to build a clean architecture system from scratch. You're also going to learn what are the architectural principles behind the clean architecture and why it's so popular. You're going to learn the fundamentals of domain-driven design and how to create a rich domain model. You're going to learn about the CQRS pattern and how you can use it to design your application's use cases. You will learn how to solve validation and logging as cross-cutting concerns. You're also going to learn about concurrency control and why it's important in building scalable systems. You're going to learn about authentication and how to add it to your system. And I'm going to teach you how to use an external identity provider called Keycloak. You will also learn how to use minimal APIs instead of controllers and how to implement the transactional outbox pattern. And you will also learn about the value of testing and what types of tests you should be writing in a system implemented using the clean architecture. Now let's see who this course is for. Who this course is for and who is going to benefit from it. This course is for people who want to build production-ready applications using the best practices and understanding the fundamental principles that drive a good architecture and what are the trade-offs that you need to make from time to time in order to reap the most benefits. This course is for anyone who wants to learn how to apply the clean architecture in the real world, from someone who has built large-scale systems using the clean architecture with a lot of success. This course is for someone who wants to become a software architect and for anyone who wants to understand the architectural principles behind the clean architecture and what are the trade-offs that you need to consider. This course is also for anyone who wants to learn the fundamentals of domain-driven design and how to create a rich domain model. Now let's see what are the prerequisites for taking this course and how I'm going to share the source code with you. What are the prerequisites for taking this course? You should have at least 1 year of experience building ASP.NET Core applications. I'm going to assume that you already know what ASP.NET Core is, and I'm not going to be diving into the fundamentals of the framework. You will need to be familiar with Entity Framework Core and how to use it with a SQL database. You're also going to need Docker Desktop or a similar alternative to be able to run the application and the external systems it's going to use, like a database or an identity provider. In this course, we are going to build an application completely from scratch using the clean architecture. At the start and at the end of each chapter, I'm going to share the source code as it stands at that point of time, and you'll be able to download the zip file containing the source code. In the last chapter of this course, you'll be able to download the complete source code of the application that we're going to build, and it's also going to contain some additional features that I will build behind the scenes. You can consider this as a small gift from me to you. Now you can move on to the course and learn how to use the clean architecture to build production-ready applications. This is the first chapter of the Pragmatic Clean Architecture course, where I'm going to show you how to build production-ready applications using the clean architecture. Before we dive into the code and see how to implement the clean architecture, I think it's important that we understand the fundamentals behind the architecture, the value that it brings, and what are the problems that it's solving. So this chapter is going to be related to understanding the basics of the clean architecture, and then we're going to dive into the implementation. Architectural principles are the rules and guidelines that drive a specific software architecture, such as maintainability, testability, and loose coupling. These are high-level qualities that a software architecture should bring to the table and also enforce them by design. Speaking of design, what are some of the most important design principles that should be guiding your software development process? The most important design principles of a software architecture are separation of concerns. For example, the clean architecture separates the concerns of the core domain from the external dependencies of the system, such as databases and user interfaces. Then we have encapsulation, which is a principle that focuses on hiding information from the other components in your system and also isolating your components from the influence of the other components in your system. The next principle is dependency inversion, where you want to depend on abstractions at compile time and implementations at runtime. Then we have the principle of explicit dependencies, which states that your components should be honest about their dependencies that they require to function properly, and this in turn improves the stability of your components. I'm sure you've all heard about the next principle, which is single responsibility. It states that your components should have one responsibility only, and also they should have one reason to change. This principle promotes granular design of your components, and it also improves testability. Then we have dry, or don't repeat yourself, which focuses on reducing duplication in your code by encapsulating repetitive behavior. The next principle is persistence ignorance, and I think it's a really important concept to grasp when it comes to the clean architecture. Mainly, what does persistence ignorance refer to? Persistence ignorance is mainly concerned with how you design your domain entities, and you should do it in such a way that it doesn't matter which persistence technology you are using under the hood. So your entities could be persisted in a SQL database, a document database, or a key value store. These decisions should not affect how you are modeling your domain entities. And the last design principle is bounded context, which is a term coming from domain-driven design. A bounded context is a conceptual model grouping related entities and behaviors together, and at a bare minimum, your application should be a single bounded context, although in some cases you could have more bounded contexts inside of a single application. Dependency inversion is an important principle of the clean architecture, and it's important to highlight how the flow of dependencies looks like. So you'll notice from the picture here that the dependencies flow inwards, meaning that the inner layers define abstractions or interfaces, and the outer layers implement these interfaces. So what does this mean for the overall architecture? It means that the inner layers, like the domain layer, do not reference any of the other layers in the clean architecture, while the layer that is one level above it is allowed to reference the layer that is below. So the application layer can reference the domain layer. The infrastructure and presentation layers are allowed to reference the application and domain layers, and the layers that are conceptually on the same level of the architecture are allowed to reference each other, such as the infrastructure and the presentation layers. The clean architecture isn't new, and it's an evolution of the domain-centric architecture, where you have your core domain encapsulating your main business logic and rules, and then you have the supporting components such as the infrastructure and the presentation layers. Another way to think about it is that this is a domain-centric approach to organizing the dependencies in your application. So a few similar architectures that you may have heard of are the onion architecture and the hexagonal architecture. They all revolve around the same idea of having a rich application core containing the business logic and then having supporting components for the external concerns. Where should you use the clean architecture? If you want to use domain-driven design in your application, clean architecture is a very good choice because domain-driven design fits naturally into the domain layer of the architecture, which is the central piece of the clean architecture. You also want to be using clean architecture if you have complex business logic that you are solving. So clean architecture shines in isolating your business logic in the domain layer and through the use cases of the application layer. So if you're dealing with complex business logic, clean architecture is a good choice. If testability is one of the requirements of your project, then clean architecture is a good choice. It's a highly testable architecture because of the way your components are designed. They follow the single responsibility principle and the dependency inversion principle, which both help to improve testability. Also, if you are working in a large team and you want your software architecture to enforce your design policies, then clean architecture is an excellent choice. Now that you understand the architectural and design principles of the clean architecture and also where you should be using it, it's time to take a better look at the specific layers of the clean architecture. The central part of the clean architecture is the domain layer, which should encompass your most important enterprise logic and business rules. Things that you will typically see inside of your domain layer are your entities, value objects, domain events, and domain services, interfaces for the various abstractions that might be necessary for the domain layer. Then if you have custom exceptions, you would place them here, and also any enumerations that are helpful for designing a rich domain model. One level above the domain layer, we have the application layer, which is responsible for orchestrating the domain. It can also contain business logic that doesn't naturally fit into the domain layer, and the most important aspect of the application layer is that it defines the use cases of your application. The use cases are the drivers of the behavior in your application, and in simple terms, they are responsible for taking your domain entities and then telling them what to do, which is why I said that the application layer orchestrates the domain layer. How you would typically implement the use cases is as a set of application services containing the logic for each specific use case, or a really popular approach is using the CQRS pattern with Mediator. CQRS stands for Command Query Responsibility Segregation, and it splits the responsibilities of writing the data from reading the data into separate classes. A really popular library for implementing CQRS is Mediator, and it's also what we're going to be using for our clean architecture implementation. The application and the domain layer are both parts of the application core, and on top of it we have the supporting layers. The first one is the infrastructure layer. It's responsible for anything that is related to external systems, things like databases, message brokers like RabbitMQ or Kafka, email providers, storage services, identity providers, and the system clock are things that you will typically find in this layer. It also implements the interfaces that are defined in the layers below it. Right next to the infrastructure layer, we have the presentation layer, which acts as the single point of entry into your system, and then it's responsible for passing along the requests to the layers below. A typical implementation would be a RESTful API built with .NET, but it could also be a gRPC service or even a single page application built with JavaScript. What you will typically define in the presentation layer is your API endpoints, any middleware that you require, such as exception handling, authentication, or logging, and the dependency injection setup, which is available in .NET applications. Now that you understand the individual layers of the clean architecture, let's talk about what we're going to build in this course. What are we going to be building in this course and why? First, I want to answer what is the system that we're going to be building, and the answer is an apartment booking system. It's also important to consider why I picked this kind of system for the course. First of all, it's familiar and easy to understand. You've probably used a system like Booking.com or Airbnb before, and the problem domain should be familiar to you. Another reason is that this is not a trivial system, and there are interesting business rules and logic that we are going to be implementing, and the clean architecture is a perfect fit for these kinds of systems. And another reason why I picked the apartment booking system for this course is that it doesn't require extensive domain knowledge like a finance or a banking system would, and you will get the most benefit out of implementing a system like this using the clean architecture. So now you know what we are going to build in this course and what is the reasoning behind this decision, and I want to spend a moment discussing the direction that I want to take in applying the clean architecture to the apartment booking system. So we are first going to start from the domain layer and work our way up through the application, infrastructure, and presentation layers. I'm going to show you the best practices of implementing the clean architecture, and I'm going to discuss the important architectural considerations that you need to think about when working with the clean architecture and building a complex system. and we are also going to be applying domain-driven design to the domain layer of our application. I'm going to introduce you to some of the patterns of domain-driven design and what are the practical benefits that they can bring to your project.